Hello and welcome. Today we'll be going through the OptiAssist for Simcenter3D tutorials, the Composite tutorial 1, Composite box section. As you can see, I have already got my file loaded up. The first thing we are going to do is take a look at the layups for this model. The first thing I'm going to do is go over to the box section.fem and double click on that. This then allows us to take a look at the layups for the model. Here we can see the top, followed by the left hand side, and then the right hand side. You'll notice that the bottom side is missing, and therefore we will add that to the model. Under the laminates ribbon, we'll bring up the global layup. This will bring up the layup modeler, where we will name this one bottom. From there, we will create new ply, and this one will be known as bottom_0. The material will be carbon cloth with a thickness of 0.42 millimeters. The angle will remain 0, and from there we will define the draping input. In this case, the bottom, and click OK. Once you have done that, we will now copy this again. So right click and copy, and then click on the paste button. This similar ply will be changed to 45, as the angle will now be 45 degrees. We'll click OK. And from here, we will now click Update Global Layups and Zones. This will now apply the layup to the model. We can close the window. We will now check the layup orientation for this model. This will allow the model to behave as expected for this tutorial. Under the Simulation Navigator, we will go to the 2D collectors, right click on that, and check all. Under the material orientation, we will have the shell orientation selected and then display. From here, the arrows will represent their orientation, and here we can see that some are not aligned with the rest. To change this, we will go over to the 2D collectors again and right click, in this case the top one. I want to edit the mesh associated data, changing the material orientation method from orientation angle to vector. We can specify the vector by clicking on the drop down and clicking on the global Z axis. We'll click OK. We will now repeat this process for the other three meshes. Once you have done that, we will now check to confirm the layups are all aligned properly, ready for the simple analysis. Force update. Once you have done that, we will just repeat the previous step just to check that all the orientations are facing the right way. Here we can see it has in fact worked. Just close that down. Once you have set the orientation correctly, we will now change back to the sim context by double clicking on the box section.fem, and under the OptiAssist ribbon, select Solve. No, close Windows, and we'll take a look at the results. Here we can see the different displacements that have been caused by the bending load being applied. You can see that the maximum displacement, which is 4 millimeters, occurs at the end, with the smallest and the minimum at the other end. Once you're happy with that, we will click Return to Home, and under the OptiAssist ribbon, Composite Optimization. This brings up the 6-tabbed optimization setup window. For the first tab, the subcases, we will select box bending and then click Next. Under the Design Rules tab, we will create a new rule. We'll click New. For the name of this new rule, we'll name it 0 to 10 pliers, with the minimum being 0 and the maximum being 10. We'll click OK. We will now add this new rule to all 8 pliers, so I'll click on the top one, then holding down Shift at the bottom, and then Add Rule. Once the rules have been applied, we will click Next. Under the third tab, Grouping, no grouping is required for this tutorial, so we'll click Next. Under the Goal tab, we will keep the Goal tab to be Minimize Mass, and so we will click Next. Under the Constraints tab, we will create a new one, so we will click Add. Under the Constraints Creation dialog, we will keep the response type to be Displacement, with the upper limit to be 1, and magnitude for the direction. For the node, we will type in the label node 721 and then tick to confirm it. And here you can see it has been highlighted there. Clicking on the correct load case, we will click OK. And here you can see the new constraint that has been created. Click on Next. Here we come to the Settings tab, where we will keep the default settings where they are, except for the max design cycles, which we will increase to 40. We will click OK, and then begin the optimization. Once this is ran, we will close all the windows and take a look at the design history. Here we can see the design objective, in this case the mass, slowly increased with the composites, but then decreased to an optimized level. We will now take a look at the constraint violation, where we can see it has been reduced to around 0, so we know the optimization has worked. We'll close that down, and we will now take a look at the thickness. Under the OptiAssist ribbon, we'll click on Thickness Contour, load the results, cycle 40, and for the plot type, you can either look at individual ply thicknesses or the total. For this, we will take a look at the total. We'll click Plot, and we can see the change in laminate thickness. Once you're happy with that, we'll click Close, and we'll now update the model from those results. Latest cycle, you want to select all 4 laminates, you want to select all 4 layups, and OK, and yes, which now applies the new thicknesses to the model. This concludes the tutorial.